Welcome to aminacademy.com. In linear algebra, let us discuss about invertible matrices. An invertible matrix is a square matrix defined as invertible if the product of the matrix and its inverse is the identity matrix. An identity matrix is a matrix in which the main diagonal is all 1 and is the rest of the values in the matrix are zeros. Here, look at matrix A into A inverse equal I. That is product of a matrix and its inverse is a identity matrix. Then that matrix is called invertible matrix. Of course, invertible matrices are square matrix. Look at here. Here the matrix A equal 6, 5, 2, 4. Matrix B is 4, 16, 2, 8. Suppose we will find the A inverse here. For A inverse, we need modulus A is, that is determined A, 4 into 6 is 24 minus 2 into 5 is 10, which is equal 14. Then A inverse for the predicate order matrix is 1 by determinant value, and here change the, that is main diagonal element, that is 4, 6 and 4 here, 4 and 6, and change the sign of the rest of the diagonal. Look at here. Here I changed to 4 interchange, that is 4, 6 and 4 becomes 4 and 6, and change the second diagonal's sign, minus 5 and minus 2 is the A inverse. Look at here. First B determinant, 4 8s are 32, minus 2 into 16 is 32 equals 0. Therefore, it is not invertible. Not invertible, which means that determinant is 0, so it's not invertible. Next, find the inverse of 4, 5, 8, 7. Just here, determinant value is 4 into 7 is 28, minus 8 into 5 is 40 equal minus 12. Then A inverse is 1 by determinant into interchange the elements on the main diagonal, that is 7, 4, and change the sign of the second diagonal, minus 5, minus 8. Next, find the inverse of matrix B, which is given 4, 3, 2, 1, 2, 5, 7, 8, 6. Here, this is 3 into 3 order. This is not like this method. You have to follow here. First, you have to find the determinant of B. Here, 4 into that minor is 2 into 6 minus 8 into 5 minus 3 into 6, 1 into 6 is 6, 7 into 5 is 35. Therefore, minus 3 into 6 minus 35. Next, sign is positive. 2 plus 2 into plus 2 is here, then minor is here. 8 into 1 is 8 minus 14. 8 into 8, 2 into 7 is 14. So we have simplification. We have determinant value is 187. Now here we have to find BT now. BT means transpose of B. That means rows become column, column becomes rows. Look at 4, 3, 2, here 4, 3, 2. 1, 2, 5, 1, 2, 5 is a column. 7, 8, 6, 7, 8, 6 is a column. Third row becomes third column. Now we have to find the cofactors of each element of BT. Here 4 for cofactors of 4 is first row first column, that this is a minor. So 2 into 6 12 minus 5 into 8 40. 12 minus 40 equal minus 8. Then second cofactor of 1, change the sign, order. Here positive negative like changes the sign. Now cofactor of 1 is the first row second column, but cofactor is 3 into 6 minus 2 into 8. 3 into 6 18, 2 into 8 is 16. So by simplification it's minus 2. Then for the 7 is now for 7 positive, then 7 is first row and third column, so this is a minor. So 3 into 5 minus 2 into 2. 3 into 5 is 15, 2 into 2 is 4, this 7 comes. For 3 is change the sign as minus. Here 3 is in the second row first column, the minus are 1 into 6 minus 5 into 7. 1 into 6 is 6 minus 5 into 7 is minus 35. Like 2 is second row second column, the minus is 4 into 6, 24 minus 2 into 7 is 14. Like you have to find all cofactors of all elements. So here 9 elements which you found. Then this we have to find adjoint of B. Adjoint of matrix B is, you have to write this first row, that is minus 28 minus 2 11. Then second is 10 minus 18 minus 29 10 minus 18. Third is 6 minus 11 5. These are adjoint B. Now by definition, inverse of B equal adjoint B over determinant B. Adjoint B is 1 over determinant B is 1 over 187 into adjoint B is here. So we got here inverse of matrix B. Then we'll do next one. Look at here, find inverse of matrix A is 1 1 1 0 1 2 1 2 4. This another method we can find the inverse of this 3 order matrix. Just A inverse, let it be A inverse is x1 x2 x3 y1 y2 y3 z1 z2 z3. That is, it is invertible. That means you have to find the inverse of this matrix. A into A inverse is so A is given as 1 1 0 1 2 1 2 4, and this is a inverse matrix. Then look at here, this is equal to identity matrix, that 1 0 0 1 0 1 0 0 0 1. The diagonals are 1. Now look at this multiplication, 1 into x1 plus 1 into y1 1 into z1 equal to 1, equal to this one. The second elements, that is z, second rows with first column, 0 into x2, that is 0, 1 into y2, 2 into z2, that is the second equation, that becomes 0. Third is third row with the first column. Then 1 into x1, 2 into y1, 2y1, 1 into x1 is x1, 2 into y1 is 2y1, 4 into z is 4z1 equal to this third 0. Like for these elements with the second column we have to multiply, that becomes these equations. And next at equating the second column. Third is third row with the that column, 1 into x3, 2 into y3 plus 4 into z3. So we have that equations. That means third column with this, third column with third row, we have 0 0 1. So we are having simultaneously 9 equations. Then we can solve these 3 equations by getting x1, x2, x3. That is x1, y1, z1 you can find. Like the second set of 3 equations, we can find x2 equals -2, y2 equal to 3, z2 equal to -1, simultaneous equation. Like third set, x3 equal to 1, y3 equal to -2, z3 equal to 1 by solving this. Now we are getting here 9 elements. Substitute that elements in A inverse is x1, x2, x3, y1, y2, y3, z1, z2, z3. Substitute. This is the A inverse. Here A inverse equals 0, -2, 1, 2, 3, -2, -1, -1, 1. This is the A inverse. Suppose we can check this like this is A into A inverse. That means we are having A is this and X is x1, x2. We are having this equation. If you multiply A into A inverse, we can get identity matrix. Now, next question, look at here. We have to prove this AB inverse of AB is equal B inverse and A inverse multiplication. We have to prove, show that AB is also invertible, and A and B are invertible matrices. Then we can prove A dot A into B, product of AB also invertible. Now look at here, associative law, that is first using associative law, multiply AB with B inverse A inverse equal, that is A into B into B inverse, B into B inverse and with A inverse. Which is equal A into B into B inverse is I and A inverse. Now A into A inverse, A into identity is A and A inverse, which is equal I. Then second, B inverse A inverse, multiply this side with AB, which is equal B inverse by associative B inverse of A inverse into A B inverse of A here also look at B inverse A inverse A inverse A is here into B, which is equal, so you can write clearly, then which is equal A inverse IB, which is equal A inverse I is A inverse I is A inverse into I is A, then B inverse B is I, so which is equal I. then we can say AB inverse equals B inverse into A inverse. Here, so far we have done about invertible matrices, that is explanation, as well as we did some problems. We have done. Please subscribe our YouTube channel.